Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. Today's topic of discussion is 1 MCQ. So the question is, what is the major product of this reaction? And you can see here 4 options are provided and one of them is the right answer. Students, it's actually a multi-step problem, so that's why I request you please pause the video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. And don't hesitate whether your answer will be right or wrong, because self-evaluation is essential for improvement, and that's why you must try. I believe you have tried by yourself, so it's my turn to give you the right answer. So if you look at this problem, this reaction is associated with 3-step reaction. The molecule you can see here, and it is reacted first with HF in terms of heat. Second step, mix acid, so sulfuric acid, nitric acid, heat, and third step is this amine. Sorry. So we need to go stepwise. Now first of all we need to understand this molecule HF. So remember, this HF is actually the weakest acid among all halogens. So that's why you can say that, sir, this HF bond is pretty strong. So how it reacts? Furthermore, if we say that fluoride radical is not a good leaving group, so not a good leaving group as well as not a good nucleophile. So how it can participate in this reaction? Because if we look at closely, this molecule is nothing but, you can consider that it has an aromatic carbon chlorine bond which have partial double bond character. Not only that, there is, so if I say it's a CCl, means, let me draw it again. So this is carbon attached to 3 chlorine. Okay, so this is the structure. Now actually what happens here? Here in the first step, fluoride act as nucleophile, but sometime before I told it's not a good nucleophile. Then how this reaction can happen? Actually student, this reaction happens under relatively drastic condition. You can see that HF in terms of heat. Now it is true that it's not a good nucleophile, but chloride minus is relatively a better leaving group, point number 1, and the produced carbon fluorine bond is pretty strong bond. Student, remember, this is one of the most strong covalent bond in organic chemistry. An example of this strengthness is the Teflon, which is used as a coating material in cookware. I've already uploaded a dedicated lecture on this topic. Please visit for better understanding. Now from these we understand, since the carbon fluorine bond is very strong, that's why fluorine act as nucleophile and replaces this chlorine with fluorine. Now you can think that, sir, if it is possible, then why this carbon chlorine is not substituted? This is because this CaCCl has some partial double bond character. Why? Because it could be donated, it could be open, so it could not be replaced that much easily. Not only that, this reaction is type of a aromatic nucleophilic substitution, and for that purpose stronger electron withdrawing group, or more specifically electron withdrawing group with -R effect, is essential. Now you consider either CCl3 or CF3, both have the withdrawing effect, but they are sigma withdrawing or -I. They have the -I effect, and this chlorine's position is far away. You can see 1, 2, 3, 4 after 4 carbon, and we know this sigma withdrawing or -I effect doesn't operate for longer distance, so that's why the effect is low. So only carbon chlorine bonds are replaced with carbon fluorine bonds. And remember student, this is one of a very efficient way to form carbon fluorine bond from carbon chlorine bond. Okay, so this much we understand. Now if you look at CF3 versus CCl3, this CF3 have a very strong sigma withdrawing or minus I effect. Why? Because in this case the carbon atom is attached to 3 fluorine atom, and we know the fluorine is the most electronegative atom in the periodic table, and it is considered, student, the electronegativity of this CF3 is in between fluorine, so it is lesser than fluorine and it is greater than chlorine. So this is a very shocking result, but it is the truth. So this is actually a very strong withdrawing or minus I effect having group. So its effect, so it's actually deactivates the nucleus. Consequently, you can expect that aromatic electrophilic substitution, if you want to carry on this part, I am not talking about parachloro, just I am talking about the contribution or consequence of CF3, which will result in this meta substitution. So this position is meta with respect to CF3 group. So this part is over. Now let's focus on the another chlorine. Now we know that these chlorines have actually lone pair. So it has 3 lone pair, and these lone pair could be donated inside this benzene ring. So how this happened? This happens by the plus R effect of this halogen, and that's why these halogens are orthopara orienting. What do I mean? So if you look at these two positions, this is ortho with respect to chlorine, and this is para with respect to chlorine. Now the para position is blocked, so this is not possible, but these two ortho positions are free. So in this case, actually, student, what happened? The plus R effect, this donation is lesser compared to the minus I effect of halogen. I mean, halogen have stronger minus I effect or sigma withdrawing compared to this plus R effect. So that's why you can say this halogen substitution results in deactivation of aromatic ring towards aromatic electrophilic substitution, but it is orthopara orienting. This is quite special character, because generally if a group is withdrawing, that is meta detecting or directing, and if a group is donating, that is orthopara. So it's an intermediate and special case, please try to remember. Now in presence of this mixed acid condition in which the electrophile is actually Na2 plus, these aromatic electrolytic substitution occurs, and ultimately what it produces, these two ortho protons are substituted by NO2. So actually it's a ortho dinitro derivative. Now just student, look at one side halogen withdrawing, minus I is greater than plus R. Second case, two nitro groups extremely withdrawing, both minus I and minus R effect, and CF3 group that is also stronger minus I effect showing groups. So all this makes this benzene ring extremely electron deficient. So these electron deficiency inspires this molecule for aromatic nucleophilic substitution, and in this case the lone pair on this nitrogen or di-N-propyl amine act as nucleophile. So it attacks, so actually it's a very electron deficient molecule, so it's prone for nucleophilic attack or aromatic nucleophilic substitution. So mechanism I am not going, so it attacks and this benzene ring utilized in this delocalization of negative charge, and at the end this Cl leaves. So it produces these di-substituted amine attached with this benzene ring. So this is the product. These molecules have some specific character which I will discuss after some time. So here if you look at the key steps and name reaction associated with these processes, the first step is CF bond formation by replacement, actually or substitution. C means chlorine is substituted by fluorine, produces this CF3 group. Second step, aromatic electrophilic substitution, or more specifically nitration using mixed acid, and here this nitration is position specific, ortho with respect to 2 chlorine and meta with respect to CF3. So this is, and third step is aromatic nucleophilic substitution, and in both case aromatic electrophilic and nucleophilic carbon nitrogen bond formation happens. Now so what is the answer of today's discussion? That chlorine is replaced by this amine and this CCl3 is converted by CF3. But here we can see all 4 options are nitrogen substituted. So let's not focus on this. First focus on the all CCl3 substituted by CF3. So you can consider this either B or C. Now next question is that, okay, there will be meta with respect to CF3 nitro substitution. So meta, yes. So this is the answer. Now if this problem appears in your exam less than 30 seconds, how can you come to the right answer? Easily. Now for that purpose you need to understand the nature of the functional groups. First of all, if you look at these group, these have two types of carbon chlorine bond. This is benzylic, so sp3CCl, and obviously in this case here it is sp2CCl. So this is the difference, and we know sp2CCl means aromatic halides are stronger. So in this case HF will replace only these benzyl derivative which are prone for nucleophilic substitution. So if you understand this much, then option A gone and obviously option D gone. Now second point, that nitric acid and sulfuric acid heat. A simple answer, student. CF3 is actually a stronger minus I effect, so it is meta directing. Not only that, this chlorine is orthopara orienting and deactivating. So obviously these two statements indicates the nitration on this position. So ultimately, if you think now this option C gone, which is left? Option B, answer. So if you think in this way, student, you don't need to go to the last part of this reaction. You can conclude to the right answer by logical choice. But I always say study as much as you can. Now, in conclusion, what you have learned today, that CF bond is one of the most stable covalent bond due to proper orbital overlap. Actually, both belongs to the second row in the periodic table. So overlap is better. And in this case, CF3 group is extremely electron withdrawing in nature. I mean very strong minus I effect. That's why its electronegativity is considered it's in between fluorine and chlorine. And remember, due to this minus I effect, CF3 group is actually meta directing and deactivating. However, the Cl is actually orthopara orienting and deactivating too, because its minus I overrides the plus R effect. So since the para position is blocked by this CF3 group, the nitration occurs at two ortho positions. Finally, NO2 group in the two ortho positions make the benzene ring further electron deficient, and consequently aromatic nucleophilic substitution happens by that secondary amine and it replaces the chlorine atom. In this case, the secondary amine is nucleophile and Cl leaves. And finally, the benzene carbon CF3 bond is extremely strong bond, because this you may consider that, sir, this benzene CF3, is it very strong? Yes, it's very strong. That's why if you try to oxidize this benzene, it results in trifluoroacetic acid. Although if you try to oxidize this molecule, this toluene, it results in benzoic acid. So I have made a dedicated lecture on this topic. You may visit for doubt clearance. Now let's go to the application of this molecule, our target product. Its name is actually Trifluralin. So this molecule actually is it's widely used as herbicide. So you may consider this is an application of CF bond formation. So this CF bond containing molecule, and this molecule is actually extremely utilized. Okay, so that's the importance of fluorine chemistry, which I'll make many videos in future too. So, and if I consider the reference part, this problem is taken from this US patent. You can verify. And one interesting chemistry I want to inform you, student, that if you take toluene, so this is the toluene molecule, and if you treat with chlorine and iron powder, so it results in ring substitution, means aromatic electrophilic substitution. Why? Because first chlorine reacts with iron and produces, student, iron 3 chloride, which acts as Lewis acid and which results in aromatic electrophilic substitution, and it results mainly ortho and para, although some meta is also produced, Now our focus was mainly on para isomer. So in the next step, this chlorine is treated with this para chlorotoluene with UV light. So what it does, it actually converts this CCH3 into Cl3. Okay, fine. Now after that, if you treat this with HF, it produces obviously again CF3. So you can see it's very interesting, CF3. Now, this part we understand, and in this way, this finally this actually trifluorobenzene is produced. This is the patent, and later stage, as I told, that is means nitration followed by nucleophilic attack. So this is the preparation, means reference for the preparation of this starting material of today's discussion. It's very interesting molecule. So this is the end of discussion. I thanks everyone for watching this video. If you really enjoy the content, please help this channel to grow. Subscribe, like, comment and share this video among your friends. And if you want to know further, you may visit to other of my channels. So this is the end. Thanks for watching. See you in my next video. Bye bye.